Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems. Hi everyone, Patrick McFadden for Distributed Data Show. We are live at Developer Day, Texas, here in Dallas, and I have Carter with me today. How you doing?
Doing well. Thanks, Patrick.
So tell everyone about yourself. What do you do?
Sure.
Why are you interesting?
Well, I don't know if I'm interesting, but I'll at least introduce myself. So I'm Carter Bradford. I'm the president of Percassi. We are a technology consulting company. We like to say we take data, technology, and creativity and use that to turn great ideas into digital experiences. So the way that sort of manifests itself is we have really three core areas that we work in. Starting on the data side, so everything from machine learning and analytics to modern data platforms. Mm-hmm. We've got an engineering practice focused on cloud native, and then we have a user experience practice. So really anything that any kind of technology that impacts or touches a human, we have folks that optimize that interaction.
Wow, all right. Well, okay, so data is kind of taking over the world, right?
Absolutely, that fuels everything.
If data's taking the world to hell, you're going to hold the handle, right?
That's right, that will be right there with it.
That's probably not in your mission statement, right?
No.
All right, good. But it is true. I mean, what you and I have talked about, we had a little talk beforehand, it's very interesting, but let's start with a little background. What is your background with Cassandra, DSE? How did you come here?
Sure. So we get started using Cassandra and DataStax actually a while back in 2012. So we were working with a major retail customer, and they were starting a journey around customer personalization, getting to know their customers, both how they shop in store, how they shop online, merging the behavior and the transactional data, and then being able to take advantage of it to truly optimize experiences all across the board. So that all obviously started with a set of data analysis that allowed us to really kind of understand the customer. Once we did that, we needed a way to actually operationalize that. We needed a way to get those insights out and push them to a point of sale system, push them to the e-commerce site, mobile devices in real time and at scale. And that's where Cassandra came in and DataStax came in, allow us to do that at a scale that we couldn't do with the traditional data platform.
So really it was about scale.
Absolutely. Yeah. Scale and speed.
Speed, yeah. What about uptime? Those are your big three. But I think uptime is kind of table stakes anymore right now.
True, but that was a big part of it. So obviously if the digital sites aren't up and running, you're not making money in retail. So making sure that when you've got the ability to scale up during peak season, so obviously we're getting close to that point of time of the year right now, we wanted to make sure that it was always available.
So the use case specifically, I think, is really fascinating. When you started describing it, I first was like, what are you talking about? But let's just get into it.
Sure.
What is the use case you're using Cassandra DSE for right now?
Yeah, absolutely. So it's really, when you think about it, we do a lot of work in the data science space. And people tend to think of data science as folks sitting around looking at data and cranking out these models that then can produce interesting insights, can help businesses make good decisions.
That's about half of the talks at Strata.
It's exactly. And so that's all well and good. You have to do that part. But then how do you actually make it operate at scale?
Right.
How can you actually take those insights and make sure that they're being delivered to every single channel, every single other technical component that might depend on or benefit from them? And that's really where Cassandra came in. So it starts at the beginning of the pipeline, where we are ingesting massive amounts of data, whether that's transactional data, customer behavior data. And we want to try to get some insights on that data in real time. Because those are ultimately features or aspects and components of the data that are useful for those machine learning models. So it really starts at the point of ingest. So we're doing things like, as an example, we'll use real-time processing to create real-time aggregates of data, so over specific windows of time. Those then get fed as features into the machine learning models. The models then get trained, and then we use Cassandra as a model repository. So at the end of the day, we've done all this work, we've generated the insights, and now I'm actually at the point of interaction. So whether it's a website or whether it's a mobile device or any kind of machine-to-machine interaction, Cassandra serves those models, we score in real time and deliver the insight and power the experience.
That is the most fascinating thing about this, is using an operational database like like Cassandra. Cassandra's not the database you use when you need to do a lot of ML, big analytics, you know, terabytes, petabytes of data, like what's going on. But I think, and I've said this before, that's almost too late to manage your data. So having an operational data layer with those ready to go models is really, I think that's genius. I think that's great because you and I were talking about this last mile problem. When collecting a lot of data, now what do you do with it?
Absolutely.
It should make you money, right?
Absolutely, that's what it's designed to do. So this is the layer that, one, it has to be fast, right? Because if you think about it, personalizing experience, and we'll use retail as the example, right? Personalization isn't the only thing going on, right? You've got to serve up product information. You're rendering carts. You're making all kinds of decisions. So the personalization component can't impact the overall customer experience. It has to enhance it. So we're talking about the need to do this in sub 10 millisecond time frame. So you've got to have that speed, and two, you have to have the reliability and scale. And that's really where having something like DataStax kind of at that last mile on kind of the delivery end, or we like to call it the activation end of the data pipeline.
That sounds cool too.
Is really important.
Yeah, well, and it's very similar, and it sounds very similar to like fraud detection.
Absolutely.
You don't wait around for fraud detection.
Absolutely.
That's a now. Yeah, if someone's using my credit card in another country, I want to know. But it's fascinating to me. You're doing the same type of activity for fraud detection. Fraud detection would do for retail experience.
Yeah, we're actually working with a customer right now doing exactly that.
That's amazing.
So very similar thing. We're coming in, we're getting insights on the data upon ingest, and then we've got models that then are scored in real time and can indicate fraud or not fraud.
So let's get into some of the nuts and bolts here. So it seems like if you're building an operational data layer that is a repository of models, is the data model very dynamic, or are you storing blobs? How are you doing that in a data model?
It really depends on the type of model itself. So in some cases we may use an algebraic model, right? I mean, really it's a matter of taking very well-known and tangible features out of the data, so things like number of past purchases, et cetera, and applying them to an algebraic model. And many times in more complex models, it's actually quite different. So the output of a model is a set of matrices, right? So we use, similar to what you said, to Cassandra to effectively store blobs. We pull out the relevant portions in real time, do the matrix math, the matrix multiplication, and then we get a result in real time.
How often are those updated, though? You were saying that there's a lot of dynamic in the model and you're feeding features in, but the features change, not the model.
Absolutely.
Okay.
Well, it's both, right? So obviously the data changes. Sometimes the features that are used in the context of the model will change. So one of the things that we found is that models can't remain static, right? Models incur technical debt just like every other type of software. So that feedback loop is always important. And what we typically do, and it really depends on the use case. So in many cases we're training models once a day. In some cases we may be training models once an hour.
Right. So I can tell you an objection I can hear in my mind. I can hear you saying it, I'll say it for you, is this seems like something I would want a strong ACID transaction for, but you're not doing that, and you haven't done that for a long time.
Right.
Why?
In this case, it's not really necessary, right? And again, it depends on the use case, but for the purposes of personalization, you have to think about what's the penalty of getting it wrong. Right. What's the penalty of not being 100% correct? So if it's a banking transaction, and you want to know exactly what your balance is, and $100 it makes a difference. In this case, from a personalization standpoint, if I am serving up based on yesterday's model, chances are the penalty for doing that is very small.
Because it's such an evolution of a model, not a radical change.
And from a customer's perspective, using the retail model, if I see, yesterday I thought you would prefer a black shirt, today you might prefer, the model says you prefer a green shirt, are you really going to be aware that it's a bit stale, right?
I'm already creeped out enough with my retail experiences online, so what's a little more,
you
right?
only knew everything behind the curtain, right?
And it's funny because banks, are commonly used as ACID, but banks have never been strongly consistent because that's where overdraft and they made a whole business around eventual consistency. Sure, there are transactions in the world. I think commit rollback is probably more important than making sure that you have a strong transaction. But you're right. There's what you pointed out. I think is such a clear thing. Know your data. Know your use case. You can just throw features at something, but is that really needed? Do you need the cost of that? No.
Right. Absolutely.
Yeah. That's really interesting. So, so where is this going in the world? So you're using ingest for like in the stream right now. It seems like everybody's doing in the stream. Not a lot of. Do you also augment your stream with like back-end processing, or is it just all stream right now?
No, it's definitely both. It's definitely both. I think it's, depending on the use case, depending on the type of data involved, we build models, we do analytics both in real time and in batch. There are certain use cases where the volume of data or the type of model that we're trying to build just doesn't necessarily lend itself to doing real-time analysis. Right. But there are certain things, kind of continuing on, take fraud analysis as an example, or even doing contextual changes to an e-commerce site as the customer is browsing, right? Based on who they are and what they're doing at that moment. Those are perfect cases for doing analytics in the stream.
It seems like that's where more is going to the stream because you can't wait.
Absolutely.
Can't wait. Yeah, data procrastinators is what I call them.
Yeah, absolutely.
You can't be a data procrastinator.
Yeah, there's some use cases where the opportunity is lost, right? If you wait till tomorrow. Right?
Yeah, I'm buying a shirt right now.
Exactly.
Not tomorrow. I don't want to get an email saying, "Oh, you should have bought," and then I'm going to have a regret. I don't want to live with regret. I want now.
You're right. Exactly. And that's what the retailer wants.
Yeah.
They want you to see.
And using the right data layer for that is really important.
Absolutely.
Yeah. Well, this has been really interesting. I wanted to talk to you about this because it's so unique, but then whenever you distill the problem down, it's just like where people are when they arrive to Cassandra. Hey, I need scale, I need high availability, I need this volume of data that's coming at you really quick. Okay, we got a database for that.
That's right.
We can fix that problem. But thank you very much, Carter. I really appreciate you being here.
Absolutely.
This
Thank you,
really
Patrick.
Interesting.
Happy to do it.
All right, everyone. Well, we'll see you next time. Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.